In late antiquity, two pioneering women, Pandrosion and Hypatia, stood as bridge builders dedicated to preserving classical mathematics. However, the legacy of their intellectual contributions was subject to two distinct forms of erasure. While Pandrosion's work was marginalized and obscured through textual bias and historical misattribution, Hypatia's life and work were brutally silenced through physical violence. Correcting the Ink, Remembering the Blood examines this intersection of mathematical preservation and historical erasure. By revisiting the manuscripts and the circumstances of their lives, we seek to restore their rightful place in history, correcting the ink of the records and honoring the blood shed in the pursuit of knowledge. As the sun began to set on the great age of Alexandrian scholarship, we entered the twilight of the museum. In this era of rising sectarian violence, the scientific imperative shifted from the thrill of new discovery to the urgent labor of preservation. The foundational pillars established by Euclid, Archimedes, and Apollonius were literally and figuratively crumbling. Amidst this decay stood two critical figures. Pandrosion, the 4th-century pioneer recognized as the earliest known female mathematician, and Hypatia, the last great Neoplatonic scientific pedagogue. Together, they navigated a slowing intellectual landscape, fighting to safeguard the remnants of classical geometry and philosophy before the dark clouds of antiquity fully descended. Separating myth from reality is essential to honoring these scholars. While modern legends romanticize Hypatia as the inventor of the astrolabe or a secret pioneer of heliocentrism, the historical record reveals a different, yet equally vital, genius. Their true power was pedagogical and editorial. They were the master curators of antiquity, editing Ptolemy's Almagest and writing definitive commentaries on Diophantus's Arithmetica. By refining instruments like the hydroscope and astrolabe based on existing principles, they acted as the essential intellectual bridges. Their meticulous preservation and teaching allowed complex ancient mathematics to survive the collapse of their world, ensuring these foundations reached the modern era. In truth, their editorial corrections saved the scientific future. Before Hypatia, there was Pandrosion of Alexandria. Emerging in the 4th century CE, she likely stands as the true earliest known female mathematician. Her existence is preserved in a singular, paradoxical source, Book 3 of Pappus of Alexandria's mathematical collection. Driven by a fierce academic rivalry, Pappus sarcastically dedicated his work to her, harshly mocking her male students for confusing problems with theorems. Yet, in his attempt to disparage her, he inadvertently immortalized her. His public hostility suggests a woman whose intellectual reputation was significant enough to threaten his own. Through this textual bias, Pandrosion's brilliance survives, not through praise, but through the defensive echoes of a contemporary who couldn't manage to ignore her. Pandrosion's mathematical prowess is best exemplified by her approach to the doubling the cube challenge, a classic ancient problem requiring the calculation of cube roots. While her contemporary, Pappus, dismissed her work as lacking formal proof, modern analysis vindicates her genius. Pandrosion developed a sophisticated 3D recursive geometry method that was numerically accurate, moving beyond the standard 2D planar approaches of her time. Furthermore, her students produced an exact method for constructing the geometric mean that was notably simpler and more elegant than Pappus's own. These contributions reveal Pandrosion not just as a teacher, but as an innovator who pushed the boundaries of three-dimensional mathematics, offering practical, accurate solutions that rivaled and, in some ways, surpassed the established masters. The erasure of Pandrosion was a deliberate act of linguistic correction. In the original 4th century Greek, she was addressed as Kratist Pandrosion, using the feminine vocative. However, between 1878 and 1982, translators like Friedrich Hulch found the concept of a female mathematician absurd. They systematically altered the grammar to the masculine Latin Pandrosio, effectively rewriting her out of history to fit their own biases. It wasn't until the late 20th century that scholars like Alexander Jones and Raviel Netz reclaimed the original feminine translation. By restoring the Greek grammar, they proved that what earlier historians dismissed as a typo was, in fact, the suppressed historical truth of a brilliant woman's existence. Hypatia of Alexandria was a formidable Neoplatonic pedagogue and the daughter of the mathematician Theon. A prominent public figure, she advised civil magistrates and taught a diverse assembly of pagan and Christian students, including the future bishop Synesius. Her teachings centered on Neoplatonism, a philosophical ascent from physical reality toward the one. This rigorous detachment from the material world is captured in the famous anecdote of her deterring an infatuated student with her menstrual rags, a stark reminder that the body is not the source of true beauty. For Hypatia, the goal of reason was a mystical union with the divine, requiring a disciplined intellect to look past the imperfections of nature and reach for the pure, non-material ideal. Imagine tracking planetary orbits through long division using only the Greek alphabet. No Arabic numerals, no zero, just pure intellectual grit. This was Hypatia's reality. Her genius lay in making the arduous accessible. She interpolated a vastly more efficient sexagesimal division technique into Ptolemy's Almagest, refining the standard for future astronomers. Beyond raw calculation, Hypatia was the ultimate editorial bridge. She penned clarifying commentaries on Diophantus's Arithmetica and Apollonius's Conics, translating complex algebra and the geometry of hyperbolas for a new generation. By demystifying these foundational works, she ensured that the brilliance of ancient mathematics didn't just survive, it remained usable, standing as a vital link between antiquity and the modern world. Alexandria's intellectual light was caught in a deadly tension triangle between competing powers. On one side stood Orestes, the Roman prefect and Hypatia's close ally, who fought to maintain traditional civic order. Opposing him was the ambitious Bishop Cyril, a religious authority bent on expanding ecclesiastical power by targeting non-Christian populations. Cyril's agenda was enforced by the Parabolani, a charitable brotherhood turned militia. Caught in this crossfire, Hypatia became the ultimate political scapegoat. Dark rumors suggested her mathematical tools and philosophical influence were satanic wiles, preventing a reconciliation between church and state. This volatile mix of political rivalry and religious fervor transformed Hypatia from a respected scholar into a target, setting the stage for a collision between reason and radicalism. In March 415 CE, the loud violence of martyrdom brought a horrific end to Hypatia's life. The tragedy began with an ambush, as the Parabolani mob, led by Peter the Lector, dragged her from her carriage. She was forced into the Caesareum, where she was stripped and brutally murdered with ostercois, jagged roofing tiles or oyster shells. The final act of physical erasure took place at Cinaron, where her body was dismembered and burned. This brutal execution shocked the Greco-Roman world. While it did not immediately end Alexandrian science, it served as a chilling turning point, marking the end of tolerance for classical intellectual life and the beginning of a darker, more dangerous era for reason. In our final analysis, we witness two distinct mechanisms of erasure that sought to silence these brilliant minds. For Pandrosion, it was the quiet violence of the pen, a textual assassination where modern translators, blinded by bias, altered her very identity to fit a masculine mold. For Hypatia, it was the loud violence of the mob, a physical execution by zealots, followed by centuries of romanticized myth-making that obscured her actual scientific rigor. While Pandrosion faced the ridicule of academic rivals like Pappus, and Hypatia became a political scapegoat for religious leaders, both women shared a singular mission, preserving the mathematical foundations of the past. Together, they remind us that history is shaped not just by what we discover, but by what we choose to remember. In this final look at the restored palimpsest, we see the true scale of the legacy left by Hypatia and Pandrosion. They stand at the narrow bridge in the bottleneck of late antiquity, connecting the giants of the past, Euclid, Apollonius, Diophantus, and Ptolemy, to the intellectual revolutions of the future. Without their tireless editorial preservation, the works that fueled Islamic scholarship and the breakthroughs of Descartes, Newton, and Leibniz might have been lost to time. History often fixates on the dramatic blood of the martyr, but the survival of human knowledge depends equally on the ink of those who were nearly erased. By restoring their names, we acknowledge the essential conduits who kept the light of mathematics burning through the darkness.